Hey guys, so I am going to be showing how to do number 4 on this paper, which is also in the description below. We have our answer here. We're just trying to find the method and how to reach that answer, which is 63 watts. I have probably looked a lot of places for like how to solve this problem, and it took a lot, trying to find out where a good explanation was. So I'm just going to show you for anybody that's watching this that might be confused as of how to solve this. So we have our knowns, which is that there is going to be some incline, right? 40 degrees, block falling, mass is 2 kilograms, velocity is going to be 5. This is a constant, so that means that acceleration is going to be 0 because acceleration is pretty much the derivative of velocity. And since velocity isn't changing, the derivative is going to be 0, therefore acceleration is 0. So now we're going to do our other knowns, which are the vectors components, which this is weight, and this is normal force, and normal force is the force between the block and the surface. And since the surface is pointing at a 40-degree angle, the normal force is always going to be perpendicular from that surface, so that's why it's pointing this way. So since our surface is also inclined, our weight is also going to have an x and y component, because look at the way our block looks. There's no way that it doesn't have an x and y component. So we're going to draw our xy coordinate according to the motion. So I have my y here and my x here. So since our motion is going this way, I have my x going down this way. So this is going to be our weight of our x, or our weight of the x component, and our weight in the y component. So now we can use this formula, P equals V times F times V. I don't know if that's hard to see. Well, yeah, that's kind of hard to see. But P equals force times velocity. And the only force in this case is the gravitational force because it's falling. So that means that F is equal to the weight. Now, which weight though? So since there's only motion in the x direction, the weight for our force is going to be the weight in the x direction because there's no motion in the y. So we do weight, and then how do we find this weight of x? Well, we can use some old trig or calculus tips with SOHCAHTOA. So this is the angle we are looking at, right, to find this. What are our knowns and what are we trying to find out? So we know this weight vector. We do not know this weight of x, which is what we're trying to find here, right? So based on this angle, we know our opposite, and we don't know our hypotenuse. So that would be sine, right? Because this would be adjacent, and this would be opposite, and that's hypotenuse. So this would be weight times the sine of theta. Now plugging this back into this original formula, we now have P equals W sine theta times velocity, where weight is mg, which is a known formula, and sine theta times v. M is 2 kilograms. G, which is gravity, is always 9.8 meters per second squared. Sine of theta, which is 40 degrees, times our velocity, which is 5 meters per second. Now, we are going to multiply all this out. So 2 times 9.8 times sine of 40 times 5. Now, you should get something along the lines of this answer. which rounds up to 63 watts.